Whenever we check the weather, we look up at the sky. We look at the clouds, the wind, the rain. But if you really want to know what the weather is doing, you shouldn't look up. You should look down. Welcome back to Insight Engine. Today we are answering a massive question. Why isn't the equator boiling hot and the poles frozen solid? The answer is the ocean. It isn't just a place for fish. It is a giant planetary thermostat. Our oceans absorb over 90% of the excess heat from the sun. But they don't just hold that heat, they move it. Imagine the ocean as a giant global conveyor belt. At the equator, the sun beats down, warming the water. This warm water travels towards the freezing poles. When it gets there, it cools down, gets saltier, and becomes heavy. It sinks to the bottom and slowly crawls back to the equator to start all over again. This is called thermohaline circulation. But you can just think of it as temperature and salt driving a massive underwater river. Take the Gulf Stream, for example. It pumps massive amounts of warm tropical water up the coast of North America and over to Europe. Without this underwater river, a city like London wouldn't have mild, rainy winters. It would be frozen solid, much like northern Canada. But the ocean doesn't keep this heat to itself. It shares it with the sky. When warm ocean waters heats the air above it, that air rises further. Now, when cold polar air sweeps down to meet it, we get a clash of temperatures. A warm front and a cold front. They clash. This temperature clash creates powerful high-altitude winds called jet streams. Think of jet streams as tracks that weather systems ride on. And guess who lays the tracks? The ocean. If a massive patch of the Pacific Ocean gets unusually warm, a phenomenon you've probably heard of called El Niño, it literally bends the jet stream. Now, that invisible bend can cause devastating droughts in Australia while simultaneously flooding parts of the Americas. The ocean steers the wind. Sometimes this heat transfer gets aggressive. Enter the cyclone. A cyclone is, in the truest sense of physics, a giant heat engine. To start a cyclone, the ocean surface needs to hit a magic number, around 26.5 degrees Celsius. The hot water rapidly evaporates, rising into the air. As it rises, it cools and condenses into clouds, releasing a massive amount of stored energy. That is the latent heat of vaporization that's being released. It's a lot of energy. This creates a vacuum at the surface, which violently sucks in more air. Because the earth is spinning, this rushing air starts to twist. Twist like a whirlpool, and boom, you have a monster storm. This is exactly why the Bay of Bengal historically sees far more devastating cyclones than the Arabian Sea. Its enclosed shape traps heat, providing the perfect high-octane fuel for these atmospheric engines that we call cyclones. So the next time you feel a cool breeze, get caught in a rainstorm, or watch a hurricane on the news, remember, the sky is just the messenger. The ocean is the one pulling the strings. As our planet warms, we are pumping more fuel into this great blue engine, which means our weather will only get more intense. Thank you for exploring with Insight Engine. If you learned something new today, hit that like button, subscribe, and let me know in the comments what planetary mechanism should we decode next.